So there are two special cases when we are working with integration by parts. One is what I call the circular method. We actually end up going in a complete circle with integration by parts and end up back where we started. If in this special case you cannot use the table method, it has to be done formally. And then the other is when dv is equal to dx, which is usually involving logarithms or inverse trig expressions. Again, these are not common, these are rare, but I wanted you to see them to be aware that they do exist. So the first special case being the circular. And if you notice, the circular ones are ones where we end up with like e to the x and like sine or cosine, where I couldn't use the table method anyways. So I start off with, do I know anything that has a derivative e to the x cosine x? No. I don't see anything that would make me think of chain rule. So I'm thinking product rule. So I'm going to say that u is equal to e to the x, and dv is the cosine x dx. So du dx equals e to the x, du equals e to the x dx. And then with my dv, integrate it, so I get that v is equal to sine of x. So I've got that my original integral is going to be equal to u times v minus the integral of v du. So I've got part of my antiderivative, but now I notice with the other integral, I don't know anything that has a derivative of e to the x sine of x. I don't see anything that makes me think chain rule is involved, so it's not substitution. So now I'm thinking, okay, what about integration by parts? So this was for my first integration by parts. Here's my second integration by parts. I'm going to say that u is e to the x again, and dv is the sine of x dx. So du dx is equal to e to the x, du equals e to the x dx. Integrate the dv to get that v is negative cosine of x. So I now have that. So this was from integration by parts 1. So now from integration by parts 2, I have the integral of e to the x cosine of x dx that I started with. It's equal to the e to the x sine of x minus all of u times v minus the integral of v du. So that's an integral sign. Make that clearer to see. Sorry. I now notice, wait a minute, the integral I'm at with is the one I started with. So let me get rid of my parentheses here. So integral of e to the x cosine of x dx equals e to the x sine of x plus e to the x cosine of x minus the integral of e to the x cosine of x dx. And this is why I call it circular. I could do integration by parts again, and again, and again, and I'm just going to keep running through these two steps over and over and over and over again. So instead, what I'm going to do is I'm going to take that integral that's now reappeared, and I want to move this to the other side. So I'm going to add that integral to both sides, which gives me 2 times the integral of e to the x cosine of x dx is equal to e to the x sine of x plus e to the x cosine of x. And I can divide both sides by 2, and I get integral of e to the x cosine of x is equal to e to the x sine of x plus e to the x cosine of x all over 2. But then, because this is an indefinite integral, stick a plus c on the end, and there we go. Special case number 2 is not as hard on us. It does also have to be done using the formal method. This is a case where we're being asked to, if I want to find the integral of natural log of x, or I want to find the integral of inverse tangent or inverse sine. Because this doesn't, I don't know the integral of natural log of x, which we saw in a previous example. It's not chain rule. I don't even see a product rule, but it really is a product rule. It just has been simplified to make it look like it's not a product rule. So if I say that u is equal to the natural log of x and dv is equal to dx. If I integrate dv, I get that v is equal to x. Take the derivative of u and isolate the du. I get u times v, so x times the natural log of x. I don't need the absolute values around the natural log because they didn't tell me I needed them, so we're assuming that x is a positive value. Minus the integral of v du. Notice the x and the 1 over x cancel each other, so I have x times the natural log of x, minus the integral of 1 dx, which gives me x times the natural log of x, minus x plus c. And there is our second special case.